I'll begin by finding the area of our smaller rectangle. Area is found by doing base times height, so for this problem, 4 times 5 gives me 20 centimeters squared. That's the area of the smaller rectangle. I know that the area of the smaller rectangle is 1/4 or 25% of the area of the larger rectangle. That's what it tells me in the problem. So that means that if I multiply by 4, I would get the area of the larger rectangle. So area equals 20 times 4. And I'm multiplying by 4 because if the smaller rectangle is 1/4 and I multiply by 4, that will give me the area of the larger rectangle. So the larger rectangle has an area of 80 centimeters squared. The value of the ratio of the areas will become the square of the scale factor of the side lengths. So let's start with that ratio. The ratio of the smaller to the larger will be 20 over 80, and that simplifies to 1/4. So that is the square of the scale factor. I need the scale factor in order to be able to find the side lengths. So when I think about the squares, I know that 1 times 1 is 1, and 2 times 2 is 4. So that tells me that 1/4 is equal to 1/2 squared. And so my scale factor is 1/2. Therefore, when I go from my smaller rectangle to my larger rectangle, the side length of the small rectangles are half the side length of the larger rectangle. So if this side here is 4 on the small rectangle, that should be half of what I get here. To find that, I can double. 4 times 2 is 8. So that side length on the larger rectangle will be 8. On this smaller rectangle again, it's 5 centimeters, and I have a scale factor of 1/2, so that means that this side here has to be double. And so that's 10 centimeters. So the dimensions of rectangle B are 8 centimeters and 10 centimeters.